Hello, folks, and welcome to a discussion on how to simplify rational expressions, which is a fancy way of saying how do we reduce fractions with variables in them. So, as you can see over on the left, I've already written out a few key points. I'll refer back to them as needed. But what we need to do here is factor and cancel. Those are the two key steps. And for these early questions on this CUDA software worksheet that I have borrowed, we are not even going to need to quote factor per se. We're just going to need to cancel, although I guess we kind of need to factor, kind of, sort of. But here's how I want you to think of number one here. First of all, there's a negative out front, but we've got 36x cubed. I'm going to write x times x times x just for illustration purposes. We will not be doing this on future instances, but I want to show exactly what's happening. And on the bottom, we have x squared, which is just x times x. All right, now if I really want to do hardcore overkill here, I can break down 36 and 42 into smaller numbers. 36 is 2 times 2 times 3 times 3, and 42 is 2 times 3 times 7. If we do the full prime factorization, I don't expect you to do a factorization tree on these, but if we did, and then we're going to have a war. I want you to think of any time you learned about the Civil War in school and you saw this thing about, oh, the North had so many armies and the South had so many troops, and then they had so many casualties. Even if you don't actually learn about the battles, when you flip through the history book, you see those little panels all the time, right? And so what I want you to think of is that this is a battle between the North and the South of this fraction. And so every single type of troop is going to go into battle, and they're going to fight until one side gets completely wiped out. So in the case of the twos here, there are two twos on the top, one two on the bottom. One of these twos is going to get knocked out by one of these twos up here. We keep the last two though. It's there, it stays. Likewise, we're going to cancel a three. This 3 stays, this 7 stays, but now we need to have the x's fight. There are 3 x's on top, 2 x's on the bottom. So we wipe out one pair of x's, we wipe out a second pair of x's, we've got a single x left. So altogether, what's left? Well, we got negative 2 times 3 times x over 7, or in other words, to simplify, negative 6x over 7. Now, going through all those steps is extreme overkill. I do not recommend that you write out all of this, but I want you to see what is actually happening. So how would I have actually done that? I would have looked at negative 36x cubed over 42x squared, and I would have said, oh, well, I can cancel two x's top and bottom. So let me cancel this with two of those, leaving x to the first behind. And 36 is 6 times 6, 42 is 6 times 7. Let's cancel a 6 because that is the largest common factor. And then we look at what's left. Well, we've got a negative 6x on top and we've got a 7 on the bottom, and we're done. And that is typically how I would approach a question like this. So let's consider now if we cancel the numbers 16 over 16, they're going to kill each other off completely, right? They're gone. There's just nothing. It's 1. Remember, if something cancels completely, it leaves behind 0, not 1. So do not ever write a 0 when you're doing a multiply divide thing, unless you're literally multiplying by 0. All right, so these cancel off completely, and then we've got r squared over r cubed. And so just like before, where we had 2 r's on the top and 3 r's on the bottom, it was 3 on top, 2 on the bottom before, but 2 of them are going to negate, 2 pairs, and we're going to just be left with an r on the bottom. And when you don't have anything left on the top, you're going to write a 1. This is 1 over r. Another way of thinking of this is that you're subtracting. You're going to do r to the 2 minus 3, which is r to the negative first. If you have a negative exponent, that means you shift it down to the bottom of the fraction. So this is 1 over r to the first, if you will. So there are some other thoughts on how you could approach this if you prefer those instead. All right, number 3, 16 over 28. The largest number that's going to go into both 16 and 28 is 4. So we're going to divide each of those numbers by 4. We're going to say this is 4 times 4. We're going to say that this is 4 times 7. And we're going to cancel a 4. So we have 4 and 7. Now what about the letters? P squared over P. We got two P's on the top, one P on the bottom. We'll remove one P from each, and we're left with one P remaining on the top. Number 4, 32 over 24. There's a common multiple in there of 8. So if we divide each of those by 8, we get 4 over 3. N squared over n. So we'll cancel one n from top and bottom, and we're left with 4n over 3. And we're going to keep using this same idea. So 5, we're going to cancel 7s. Negative 10 over 4. Oh, I could have actually gone farther. N squared over n is going to leave us with an n. Now note, 10 over 4 can be further reduced. 7 was actually not the best number, 14 was, but that was hard to spot with the number 70. So we'll just do a second step, that's fine. And we'll say, okay, let's take a 2 out of 10 and 4 now, so that's negative 5 over 2. So negative 5 halves n. Either you say negative 5n over 2, or you could also write it as negative 5 halves n if you prefer. Your teacher for this section, though, is going to prefer this method. All right, 15 over 30, 15 goes into 30 evenly, so this is going to be a 1 over 2. N cubed will cancel one n. We're left with two n factors on the bottom. All right, and now for number 7, we have to start factoring. Now, factor is a very nebulous word in math. Factor gets used in at least 2 different ways. And then, of course, there are all the definitions that exist outside of math, like what was a factor in your decision. But for mathematics purposes, the word factor is a noun and it's a verb. And as a noun, it means the thing that you put into a multiplication question. When you do multiplication, you say factor times factor equals product. And everything else that we use the word factor for comes from this. When we use the word factor as a verb, it means make factors. That is, turn it into a multiplication of several things, which would be factors. So we have to rewrite our expression here as factors. And the reason I know we need to consider this is because we've got a minus sign, 2 minus signs actually. But if you see multiple pluses or minuses, or just any pluses or minuses really, that means you have more than one term. So let's remember the word term is any part of an expression separated from the rest by a plus or a minus. And so we have 2 terms on the top, we have 2 terms on the bottom, and it is entirely plausible that we may be needing to factor in order to solve this. So the first kind of factoring that I recommend, I refer to as factoring out. And factoring out is just saying, do we have a common number that every term has in it? So in number 7, where it says 2r minus 4, we do. That number is 2. So we're going to write this as 2 times, and then if we pull out the 2, that's r minus 2. And then the denominator, there's nothing we can take out, so it's just r minus 2, which I'm going to write in parentheses to emphasize a point here. If we put all of these in parentheses, these are now 2 times this stuff over here. And when we come back to talking about the cancel step, well, that is a thing that is multiplied, and so we can cancel it. And therefore, our answer here is just 2. Now I'm going to come back to a couple key points here. 2 times r minus 2, this is the factored form. If we were to distribute 2 times r minus 2, we're going to get 2 times r and 2 minus 2. So 2r, 2 times negative 2 is minus 4, and that obviously puts us right back where we started. So obviously these two things are equal. The other thing that I want to call your attention to is what I've written in this red box here, which is that please, 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 I beg of you, do not cancel things if they are not already factored, if they are not written as multiplication. So what I absolutely do not ever want to see you do is this. Oh, I've got an R on the top and an R on the bottom. Let me cancel those. And then you go, what is this equal to? And you go, well, it's 2 minus 4 on the top. That's -2. On the bottom, that's a nothing minus 2. So that's -2. -2. Oh, that's just 1. Okay, please, I beg of you. I'm begging. I'm asking really nicely. Do not do this ever. That was for illustration purposes only, and I do not ever want to see that again from anyone, ever in the history of mankind. So if you cancel, it has to be multiplied, or it has to be literally by itself as the only thing. That wasn't an issue with our first 6 questions because they were multiplied. It was 36 times x to the third. It was 16 times r squared, 32 times n squared. We don't have that with 7. It's 2 times r minus 4. And if you can say that minus in the middle there, or a plus, it's not factored. If you can say it within a parentheses, okay, then it's factored. It's 2 times r minus 2. But the times is the thing that's happening on the outermost layer, if you will. So we want to make sure that at the core of what we're writing, it is a multiplication thingy, not an add or subtract thingy. So moving on to number 8. Well, 45 is just 45, nothing we can do about that. But on the bottom, we can factor out a 10 because it's in common with both of these two terms. So we're going to say that this is 10 times a minus 1. And now we attempt to reduce. A minus 1 is not going to cancel with anything, so obviously that's going to stay on the bottom. But what about 45 and 10? Can we reduce the numbers? And we can because they both have a 5 in them. 45 is 5 times 9, 10 is 5 times 2. So if we cancel a 5 with each, we'll end up with a 9 and a 2. Now, depending on your teacher, either you will leave this as 2 times a minus 1, or you will distribute it back out to 2a minus 2. I personally prefer leaving it factored, so I am going to do that. But if your teacher is particular and wants it redistributed, then multiply it back out. That's usually pretty uncommon, though. So I'm going to leave it like this. All right, number 9. The top, x and 4 don't have anything in common. The bottom, however, 3x squared and negative 12x have things in common. First of all, they have a 3 in common. But that's not all they have in common. They also have an x. We can pull an x out of both of them. There is 2 x's here, 1 x there. So at most, we can pull 1 x out of both. Yes, the one had 2 x's, but we can't take 2 x's out of everything. And if you can't take it from everything, it doesn't count. So we're going to take a 3 and a single factor of x. And so 3x squared divided by 3x is x. And negative 12x divided by 3x, if we were to reduce that, is minus 4. So we have x minus 4 over 3x times x minus 4. Well, considering this is by itself, I'm going to group it like this with parentheses, and I'm going to note that this will cancel with that. So what's left? On the bottom, we have 3x. On the top, we have canceled everything, and when you cancel everything, it leaves behind 1, not 0. All right, and finally for number 10, 15a minus 3 over 24. So we are going to factor from the top a 3. No letters because the second term doesn't have any letters. So 5a minus 1 over 24. And the 3 will cancel with the 24. So this becomes 5a minus 1 over 8. So there is your complete first page. There are 2 pages of this, so we're not done. We're going to keep going. But that should illustrate for you everything that needs to happen here. Now I'm going to hand erase all of this because I want to keep the stuff that's on the left side. Actually, there's an easier way to do this. Highlight, delete, there we go. Okay, I'm going to keep our notes on the left there. Oh, there were actually two more problems on that page even. Okay, so I guess we weren't even close to done. I was too zoomed out or zoomed in to realize. So 11 is going to be trickier because our factoring is going to be a different kind of factoring. We're going to do the opposite of FOIL. We're going to be doing the what can we multiply to make v squared minus 10v plus 25. There's no common term, right? V squared is just a v. There's no v in 25. 25 is just a number, but there's no fives in v to cancel with. So there's no factoring out that takes place. But we can write that as something times something. We got a v squared in front, so we're going to write v and v. And then we need numbers that multiply to make 25 and add together to make negative 10. Now, if they're adding together to make a negative, but multiplying to make a positive, that means they're both negative numbers. So either we have -1 and -25, or we have -5 and -5. And in order to get negative 10, we're going to use the -5 and -5. So this is -5 minus 5. And on the top, we have v minus 5. Now, if you prefer, you could have written this as v minus 5 squared, because it's v minus 5 times itself. And that's important because what I want you to recognize when we get to the cancellation part of this is that this v minus 5 cannot cancel with both of these. It only cancels with one. Just like if we had x over x squared, we wouldn't cancel the x with both of these x's on the bottom. The same is true here when it's v minus 5. So therefore, the answer to this question is 1 over v minus 5. And if you're not comfortable with your unfoiling, well, it's going to be a pretty important process throughout the rest of this worksheet. So that's something we are definitely going to need to be comfortable with. So number 12, x plus 6 is just x plus 6. But on the bottom, we need to do our polynomial, our quadratic factoring here. So we got an x and an x. We need to multiply to make -6 and add to make 5. So multiplies to 6 is 1 and 2, or 2 and 3. And we're multiplying to make a negative, so one of the numbers is positive and one is negative. We're getting a plus 5, so it must be the smaller one that's negative. And the pair that will add to make 5 here is -1 and 6. So -1 plus 6, and then we will cancel, and we are left with 1 over x minus 1. 13 is going to be easier because it's a factoring out sort of question instead. Do not cancel these 27s. No, 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 bad. Do not ever, ever, ever do that. This 27 is added to stuff. Bad, bad. Shame on you for thinking that. So instead, we're going to factor the bottom as 9 times 3x plus 2. And that 9 is now multiplied by other stuff, so that can cancel. 9 goes into 27 3 times. So 3 over 3x plus 2, and that is it. Leave it alone. Again, do not touch these 3's. The 3 is added to this 2 over here. So leave it as is, 3 over 3x plus 2. All right, 14. That's going to be a double factor, top and bottom. So I don't know how comfortable you will be with your factoring of this, but I'm going to go through this a little on the quick side. So we got a v and a v. Multiplies to -30, adds to -7 is going to be -10 and plus 3. And then we've got the same thing on the bottom, only now it's -5 minus 24. That's going to be a -8 and a plus 3. And the v plus 3's will cancel. We are left with v minus 10 over v minus 8. And we're going to do the same thing basically the rest of the way down this page. I'm going to switch to a text tool because I think that'll look a little better. All right, so this is x plus, what is that? X plus 2, x plus 6 over x plus 6 times x minus 3. So then that's going to cancel, and we're going to be left with the x plus 2 on the top, and we're going to be left with the x minus 3 on the bottom. 16. This is going to factor into x minus 9, x minus 2, over x plus 4, x minus 2. We'll cancel the x minus 2's, and we'll end up with x minus 9 over x plus 4. All right, 17. Top here is b plus 7, b minus 4, over. Now, b squared minus 49, we got to think about this one. What's the deal here? It's basically b squared plus 0b minus 49, right? We don't have any b to the first term, so it's basically 0. And if you think of it that way, the answer should be pretty quick to you if you didn't immediately jump up and down screaming, that's b plus 7, b minus 7. Because if you do the FOIL on b plus 7 times b minus 7, you'll see that you get b squared minus 7b plus 7b, oh, those canceled out, minus 49. This is the only way for that to happen. This is called a difference of squares. You absolutely should be prepared to deal with difference of two squares because teachers use them constantly when they make up these questions. Questions of this type are always rigged. They're designed to cancel down a bunch. It's going to be exceedingly rare to have something where nothing cancels. I mean, that can happen. If we made up something at random, it probably would happen. But teachers always make stuff to cancel, and one of the ways that they do this, especially if they're making up a question in their head to work out nicely, is they're going to use the difference of squares. So my experience is that when writing questions like this, it's almost always going to be that when you see two terms, a squared variable minus something, it's going to be a difference of two squares, and you should immediately be prepared to do this factorization. All right, number 18 is, whoops, we're in the wrong color. V minus 8v plus 5 over, and then we got v minus 8, v minus 3. So yeah, you're going to have to brush up on doing all this quadratic factoring. Get lots and lots of practice. We can go into how to do that if you need it, but that's kind of outside the scope of this particular lesson here. All right, now for 19, we're not going to do the unfoiling sort. We're going to do the factoring out sort. So we're going to say this is 4 times n minus 1, n minus 1 over. All right, we can't pull a 6 out of the bottom because 6 doesn't go into 20. We can pull out a 2, though. So 2 times 3n minus 10. So the question is then, what cancels here? The n minus 1 and the 3n minus 10, there's nothing we can do about those at all. Best we can do is cancel with the 4's and leave a 2 behind. So this is 2n minus 1 over 3n minus 10. And maybe you write this as 2n minus 2, maybe you don't, but this is the best we can do with it. Do not go any further. Do not do any other cancellation. Do not do 4 and 20 leaves a 5. Do not cancel these n's. That is bad. That is bad. That is everything that I yelled at you earlier not to do. Factor first because this is subtracted, then do your cancel. Okay, and finally, number 20. V minus 7 times v plus 2 over, and that's a polynomial or binomial square. It's v plus 2 times v plus 2. Which if we felt like we could raise v plus 2 squared, but we will cancel one of those v plus 2's, and we are left with v minus 7 over the other v plus 2. Why am I writing these parentheses? I don't need these parentheses. They're not wrong, but we don't need them. So there is part 2. And since we had to scroll down before, I'm going to bet that this is not everything. Go away. So we're going to continue on down, and we're going to find that, yes, there are 6 more questions at the bottom here. So let's finish this up. We already did these up here. So 21 through 26, and now these are going to get ugly. And the reason they are going to get ugly is because we are going to have to do both factoring techniques. They're both going to be a thing. So we might need more space than what's written on this sheet here. So I'm going to go back to the pencil tool and I'm going to write pretty small here. So 21, 6v cubed plus 42v squared. What is a common factor? Well, they both have a 6. They both have multiple v's, v squared to be specific. So 6v squared times. All right, once I take out a 6v squared, what's left? From the first term, there's a v remaining. And from the second term, there's a 7, v plus 7. Now, the denominator, we can pull a 2 out. So let's pull a 2 out. We get v squared plus 13v plus 42. Now, at a glance, we can cancel the 6 with the 2, but there's actually more because this quadratic down here is going to factor further. So this is 6v squared v plus 7 over 2, and we got to set up our parentheses. All right, we got a v in front, front, multiplies to 42, adds to 13. That's going to be a plus 6 and a plus 7. And the v plus 7s will cancel. So in the end, oh, and the 2s will cancel here. A 2 will cancel out of that 6. So in the end, we have 3v squared over v plus 6. And that's a much grosser kind of question. Let's be honest, that's kind of disgusting. But that is going to be how we would approach number 21. Number 22, we'll do the same thing. So we're going to factor out what we can, which is an x squared minus x minus 42. And then on the bottom, we're going to factor out a 2, x squared minus 10x plus 21. And now we've got to factor each of our quadratics. Again, I want to reiterate, this is only because these questions are rigged to work this way. In reality, you would probably not normally see things that magically have a bunch of cancels at the very end, after you do all these other steps. All right, so x squared minus x minus 42. So multiplies to negative 42, adds to negative 1. That's going to be an x minus 7 and an x plus 6. Those will add to negative 1 and multiply to negative 42. And then on the bottom, it's x minus 7, x minus 3. The x minus 7s cancel. Nothing else cancels. So it's x times x plus 6 over 2 times x minus 3. And so this is 21, and this is 22. We are not going to have enough space for all of these, so we will obviously need to start writing in the margins for the last couple. 23. Factoring out a 2 from the top. Whoever copied this got it a little scrunched, but it says 2v squared plus 10v minus 48. So 2 times v squared plus 5v minus 24 over, and then we're going to factor out an 8. 8v plus 8. Well, thankfully, the bottom at least is not a quadratic. So we don't have to do double factoring from this fraction, but we do still have to do both techniques on the top. And obviously, we're expecting we're going to get a v plus 8 somewhere. So if you weren't sure how this was going to factor, you should anticipate that something's going to cancel, and not just this 2 with this 8. So this is going to be v plus 8 times v minus 3. And we're going to cancel a v plus 8 with a v plus 8. We'll cancel a 2 with an 8, which leaves a 4 behind. So this is equal to v minus 3 over 4. And that is the final result there. 24. 9x squared plus 81x. Factor out the common. That's going to be a 9x. We have a 9 from each. We have an x from each. When we factor out 9x from 9x squared, we have x. When we factor out 9x from 81, we have plus 9. And then the bottom, we're going to factor out an x as well, but only an x. So x squared plus 8x minus 9. So then we go, but we got to factor the bottom. So 9x times x plus 9 over x times multiplies to negative 9, adds to 8. That's going to be a plus 9 and a minus 1. Plus 9, minus 1. Cancel, cancel. Also cancel these x's out front. And the only things that are left, we have a 9 on top, we have an x minus 1 on the bottom. All right, finally, 25 going into the margins. So x squared plus 2x minus 80. There is nothing I can factor out of that, so I'm going to leave it alone for the moment. We will do the other kind of factoring in a second, but I have to do the first kind of factoring to the bottom, so I'm just going to keep this methodical. I'm going to take a 2x out of the bottom here, this 2x cubed minus 24x plus 64x. So 2x times x squared minus 12x plus 32. Okay, now let's do our FOIL style factoring. We got to do that top and bottom. Hooray. I know you're thrilled. Multiplies to negative 80, adds to 2. So two numbers that are pretty close together, but multiplied to 80 are going to be 8 and 10. So it's going to be a plus 10 and a minus 8. And then from the bottom, multiplies to 32, adds to negative 12. So that's a double negative. It's going to be minus 8 minus 4. And we'll cancel the x minus 8 terms. Nothing else cancels. So the top is x plus 10, and the bottom is 2x times x minus 4. Done. 26. So 26, we need to factor out a 3 from the top, first of all. So let's do that. It's going to be 3 times r squared minus 13r plus 30 over, and we'll leave the bottom alone for this brief moment. Oh, I should move that in a little bit. That looks gross. All right, that's better. And so now if we want to factor, we got 3 something over something. All right, so our r and r, we got multiplies to 30, adds to negative 13. So it's like minus 10 minus 3. And then on the bottom, we've got multiplies to negative 70, adds to negative 3. So numbers that are pretty close together that multiply to 70 are going to be 10 and 7. Because we have a negative 3, it's going to be the 10 that's negative. So we're going to have 3r minus 10, r minus 3 over r minus 10, r minus 7. And then we will cancel our r minus 10s. And so we will be left with 3r minus 3 over r minus 7 as our final answer. And that is how you are going to factor these and then cancel and reduce. Fun times with our solving of rational expressions. If you're not sure, CUDA is nice in that it generates answers for us. So I'll just quickly scroll through here. You can pause as needed to see that, yes, that is indeed how these go. And the people who generated this worksheet did leave these undistributed. So yes, I would leave the factored versions factored. Anyway, I hope this was helpful, and we'll see you in the next one.